All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about Git stuff, learning about Git remotes, Git branching, and Git bare repos. I've made some progress since yesterday, which is great. I set up the GitHub authentication. Turns out I didn't need to do any of the personal access token things stuff. Let's say stuff. Turns out I didn't need to do any of the pat stuff um, because there is an additional authentication workflow that GitHub CLI supports, which is, I guess, that classifies as like a device code flow. It's one of those things where um, from within the terminal, they'll give you a code throughout the authentication process. Like, okay, the way that it starts out is it'll so you type gh auth login, that is gh auth login. Once you hit enter, I'm not going to hit enter here, but once you hit enter, it'll ask you a series of questions. I think I have the questions open here, so let me just read that out for you. Okay, so it's going to ask, where do you use GitHub? um, there's two options, I believe. One is github.com and the other is other, I think. I don't remember what the other option was. Mine is github.com, so I choose GitHub. The next question is, what is your preferred protocol for Git operations on this host? Now, I know I'm not doing SSH. Um, I know that I'm mainly doing HTTPS. So, and especially if I'm trying to do SSH stuff, because like locally I do SSH stuff, but that's again local. And locally I've not set up any SSH private keys. There's a key-based security mechanism. It's a concept of like public and private keys and stuff. It's a simple workflow that you can set up, which is fairly secure. Sorry, it's a simple workflow that you can set up, and it makes it so you are securely authenticated once you've completed that workflow. Once you've completed that auth flow, you're securely authenticated, and anytime you try to connect between two machines on the network, two machines that have been authenticated with each other through um, this SSH key auth flow, when you're trying to communicate between these two machines, it's not going to constantly ask you for a password. It's not going to constantly ask you to authenticate because you already have this public private key system set up. And so they have their mechanism set up to authenticate internally without bugging you about authentication. Now, I haven't set that up um, because I'm okay with having to type the password in. That's not really a very big deal. But I'm pretty sure they're not going to allow that on the GitHub side. If I do set up like a SSH setup, I'm pretty sure they're not going to allow that because in general, the password based thing, it's not very secure. In general, the password based thing is it's not recommended. They recommend the you know uh, private key, SSH key. I'm not sure what to call it. I'll just say SSH key. They recommend the key based auth flow, the key based mechanism. They don't recommend the password thing. However, because I'm on a local network, so it's perfectly fine for me. Um, but yeah, that's why I don't think they're gonna allow it. They're gonna allow the uh, password thing unless. So hold on, I'm mixing up my words. I don't think they're gonna wait. Okay. I don't think they're going to allow me to use SSH unless I set that thing up. And instead, I want to use HTTPS rather than SSH. So I selected SSH. They gave, I think they gave only two options for like the preferred protocol. One was HTTPS and the other is SSH. So I selected SSH. Then they asked, how would you like to authenticate GitHub CLI? One option was login with the browser, and the other option was to paste your personal access token directly in the terminal. And I was going to do that. I was about to do that. Um, but then, and like I thought that that's what's going to happen, even with the login with web browser thing. But it turns out that didn't happen. It used what I'm assuming is something similar to a device code workflow, device code auth flow, where they'll give you a code. You have to copy that code. So they'll generate a code and paste it in your terminal, because I was doing all of this within the terminal. They'll paste the code within your terminal. They'll ask you to copy it, and then you hit enter, and it'll open up the auth link directly in your browser. And then in your browser, assuming you are already logged into GitHub, if you're not, you have to log in first. Um, Assuming you're logged into GitHub, it's gonna, sorry, zoned out. Um, Assuming you're logged into GitHub, it's going to ask if you want to authorize so and so application to, do stuff. You authorize it, then it'll ask you to enter this code. You enter it, and after that, you're good to go. Or maybe the code comes first and then the authorization comes. I think it's the code first and then the authorization. I don't remember. One of the two. But both of those steps definitely happen. Then once you have authorized it, then you're good to go. um, Once you have done the authorization in the CLI, as in once you've done the authorization in your browser, then in the CLI, the command is currently like frozen. It's currently waiting um, for the authentication to complete. Once the authentication is complete, then it's going to store it receives some sort of token. It then stores that token. That's going to be your auth token. And further from that point, whenever you push to GitHub or pull from GitHub, if authentication is required, it's going to be using this token. So I'm authenticated. I have the token thing set up. I'm good. Um, Sorry, zoned out. Give me a second. Okay, so that is done. The next thing I did is I tried actually cloning uh, the actually this repo. This is the repo that I tried. Not this one, the central repo. This one. The central repo is basically just a repo. It's the central repo for some repo O2. And the way that I initialized it is by just creating a bare repo and pushing the entire branch to the repo. Yeah, yeah. Sorry, I don't know if I explained that very well. I created the central repo as a bare repo and it was empty. Then I pushed the main branch from from the working copy repo, which is this one, some repo o2. The central repo is called some repo o2 central, I think. But yeah, I pushed the main branch from here to that repo, and then now that's why we have this. Now we have the now this is our central repo, and anytime we make changes, so this is a central repo, but this doesn't have a working directory. Something that I haven't done is I haven't explored what the directory actually looks like. Okay, we can open this up in Yahtzee and oh yeah, okay. I forgot. This literally only holds the contents of the Git folder, the Git directory. And now it kind of makes sense that it's called some repo o2 central dot git. Now that kind of makes sense. I was like, why are we adding dot git to it? Why is that a necessity? Um, or actually, maybe it's not a necessity. Maybe it's just a naming convention. I don't, I don't, I don't know. I'll have to check. I'll have to check if something happens if I don't um, add dot git at the end of the name. Sorry, zoned out. Okay, so this is our central repo. There is no working directory here. The entire repo is basically the Git folder, the Git directory of, oh, I could have opened the thing. I actually do have the thing open here, so I could have just come here and yeah, this is our entire, this is the central repo. The entire directory, the root directory itself is just the Git repo. Whereas if we go to some repo o2, you'll see, you know, the working directory, but you'll also see the .git directory. Give me a second, sorry. I'm just checking something. Just a second. Sorry, I'm just looking at something. Okay. Yeah, sorry. I'm just looking at something. I'd made a post on social media. I was just checking on that. Okay, cool. So, uh, right. So I've set up the cloning thing. I'm good on the cloning workflow. Cloning works. We use for cloning we use SSH. I haven't used HTTPS for that though. That's something I need to keep in mind. For cloning, or for like local stuff. Well, okay, so I was about to say for local stuff, I would be using SSH if I'm cloning the repo or pulling or pushing or whatever. I would be using SSH. However, the majority of the time, the repo, the working copy, and the central repo of that project, they're both going to be residing on the same system. So the majority of the time, I think it's just going to be a regular file system, like file protocol, whatever the file-based protocol is. The majority of the time, it's just going to be that. It's going to be a local directory kind of situation. Um, so I don't need to worry about that too much. But it's good to keep in mind that if I do want to do any Git related stuff um, between two machines on my network, then I would be using SSH. This is just the workflow that I need to remind myself of. This is just a workflow I need to keep in mind that yeah, this is the case, and that's about it. So in that regard, we're kind of done with remotes because I still need to experiment a lot more, and I still am trying to understand what is going on with um like how bare repos are working, how we are able to, like yesterday we were having this conversation with Gemini. Let me just open up the conversation. By the way, I found another book, which I think I'm going to be reading a lot more. This book it was written in or released in 2021. And it's an open, or at least the book has been like published. Um, it's available as a PDF and as a hard copy. The name of the book is Dive into Deep Learning. And the book is available on archive, and you can just read the PDF. It gives you a pretty decent introduction, I would say, because it covers here's the topics that get covered. First of all, it's going to go into an introduction explaining various concepts, various machine learning concepts, and then deep learning concepts, and history surrounding machine learning and deep learning, and a couple of other things. Just you know, sort of what's a good term to use here, just to sort of whet your appetite. That's the best way that I can put it. It's the best. It's the hold on words, just to sort of whet your appetite, just to um get you interested in it. Actually, it's not even just to get you interested. This is like interesting theory. This is interesting information. But yeah, this is a whole lot of that's the introduction, right? I don't know why I'm trying to explain this so much. There's an introduction. The introduction contains a bunch of very interesting information, including including a bunch of history. Then it has a section called preliminaries where they cover stuff like data manipulation, data preprocessing, linear algebra. So with data manipulation, they're teaching you how to play around with the data. Something I liked a lot was that they're not making you go um, from all the way from the basics. Like they're not telling you, oh, you'll have to learn NumPy and or pandas and matplotlib. That was my journey, going into deep learning and data science. To be fair, that's just what I had determined that I'm going to have to do. And also, to be fair, I'm glad that I did that, because at least from a data science point of view, that is necessary. That is a necessity. So back to this. Okay, data manipulation. They pretty much keep you within PyTorch the entire time. At least, from the stuff that I've looked into so far, they keep you within Python and PyTorch. And they in data manipulation, they teach you how to play around with tensors. In data preprocessing, they why am I having trouble pronouncing things? Let me read out this some of the stuff in this. Hold on. Okay, in data manipulation, they're covering concepts like data like torch.arrange. I'm guessing that's to move around the data and change the data within a tensor. Because like with torch, you're generally if you're dealing with data sets within PyTorch, it's a whole lot of tensor stuff going on. Even like an array of arrays is also all going to be packed into one tensor. They cover multiple things, reshape, arrange, and I think there was something about size. No, size is the return. Um, reshape, okay, okay. Ones, random, or rand n. Okay, all that is great. Indexing, slicing, they're covering all of that stuff, various operations. All of this, they're sticking with Torch. They're not going away from it. They're keeping you within PyTorch. I wish I would have discovered this book early on. Today I was browsing Threads, and on Threads I saw somebody posting this saying, talking about how this goes into the this is a great deep dive into deep learning. It's great for like beginners and stuff. And actually, yes, this is great for beginners because I wish I would have seen this resource early on because I did start my deep learning journey years ago. It's just that I was looking around here and there for resources and grabbing bits of information from wherever I could. But this one PDF is packed with a lot of information. This is actually a great, not even a decent, great. This is a great starting point. So data manipulation. Then we have data pre-processing. Um, wait, no, they still go into various things. Like I'm cutting off the data manipulation thing. But there's a lot more things. There's a lot more topics they go into in data manipulation. There's also exercises after each of these mini chapters. Then in data pre-processing, they teach you how to read data sets, um, how to prepare the data, how to fill in data that may or may not be there. I don't know if pandas is coming in. Yeah, pandas comes in at this point. So um, here, I guess for now I could stick with pandas, and later I could move on to polars once I've become more comfortable with it. Dude, let me open the PDF here. Give me a second. I'm gonna uh hide the browser window and open up this PDF, and then we can take a look at this together. Deep dive into deep learning, or was it just called dive into deep learning? No, it's just called dive into deep learning. It's on archive. Yeah, let's open this up and we are good to go. Oh God, OBS crashed. Wait, are we good? Oh no. Did OBS crash? Hold on, I don't know if I'm still live. Okay, somehow I'm still live. Okay, okay, are we live? Are we live? Come on, dude. Okay. All right. Oh, I think we saved it. Um, Instead of hiding and showing the browser, I think what I should do is just you know what? It could have also been the issue of me opening up this PDF. I could be wrong though. I'm not sure. Well, anyways, this is the PDF. I'm gonna just temporarily bring this here so I can scroll through the PDF and show you guys. This is the book. This is the ebook. Hold on, give me a second. Right. Oh, I didn't transition. Now you guys can see it. Okay. Well, I mean, you could see it before as well, but it was smaller. Okay, so sorry, zoned out. Okay, so this is the book. Um, this is the book. I can I think I'll stop the RTMP feed while I'm going through this so my fans can cool down a little bit. Yeah, okay. So this is the book. The book is called Deep Dive into Deep Learning. I'm not going to scroll to the right because then that messes up the. Actually, does it? No, it doesn't. Never mind. I hit home, and not only did it scroll up, it also scrolled all the way to the left. But yeah, okay. Yeah. So the book is called Dive into Deep Learning, and here is the introduction. Actually, I can show you this thing. This covers like the various in the index. We can see the various topics. So in introduction, it gives a whole bunch of like theory stuff, theory, history, and all of that. Great. Um, then in data manipulation, they go into stuff like, well, basics, and then indexing, slicing, various operations, whatever broadcasting is. I forgot what that is. And then I think this is to do with writing the data to a file, maybe. I don't remember. Um, then conversion to other Python objects. I haven't read this. Then it moves on to data pre-processing. So reading a data set, data preparation, conversion to the tensor format, then some discussion and then exercises. Then linear algebra. It goes into concepts of linear algebra as well. Stuff like scalars, vectors, matrices, tensors, basic properties of tensor arithmetic, and various other tensor related things, various other, actually not just tensor related, it's more linear algebra related, because stuff like dot products and matrix products, matrix multiplication. What is matrix vector products? I need to look into that. But yeah, matrix multiplication, and I have to look into what reduction is as well. But yeah, it covers these topics. And then calculus. I feel like if I go through this section, I actually did explore this a little bit. I feel like if I take the time to go through this section, I will probably understand calculus, or at least this part of calculus that is necessary, the derivatives and differentiation, and also the chain rule and gradients and partial derivatives. These specific topics, I'd been meaning to look into these specific topics in um, in calculus. My problem usually used to be that because I had never explored calculus, so what I would end up doing is, in an effort to eventually get to these topics, I would start learning the basics of calculus. And learning the basics is different from like directly jumping into this. But then because like getting from the basics to this point, there's a couple of other topics in between. So I would never actually make it to this point. And I tried doing it like over and over again, but like each time I would just end up branching out, getting distracted in something or whatever. It just wasn't working out that well. Sorry, zoned out. So, yeah, it wasn't working out that well for me. That's why I never actually moved forward with learning these specific deep learning related calculus topics that I wanted to learn for a while. I feel like if I go through this, I'm going to get it. Yeah, I feel like if I go through this, then I'm going to get it. Um, okay. Anyways, moving on. It then goes into automatic differentiation, which is autograd, which is um, it's the system that PyTorch uses to calculate your gradients and also do the back propagation for you. Um, then I haven't looked into the rest of the stuff, so I guess we can explore this together. Yeah, yeah, I guess we can explore this together. So like, okay, probability and statistics. What does it say? One way or another, machine learning is all about uncertainty. In supervised learning, we want to predict something unknown, which is the target, given something known, which is the features. Depending on our objective, we might attempt to predict the most likely value of the target, or we might predict the value of the smallest expected distance from the target. And sometimes we wish not only to predict a specific value, but to quantify, to quantify our uncertainty. For example, given some features describing a patient, we might want to know how likely they are to suffer a heart attack in the next year. In unsupervised learning, we often care about uncertainty to determine whether a set of measurements is anomalous. It helps to know how likely one is to observe values in a population of interest. Furthermore, in reinforcement learning, we wish to develop agents that act intelligently in various environments. This requires reasoning about how an environment might be expected to change and what rewards one might expect to encounter in response to each of the available actions. Probability is the okay. Why am I reading the entire thing now? Let's just move on. So we're gonna look into this as well. The great thing is this. Okay, I'm not sure what is included in this package. D2L. D2L is from like it's part of this like course. Um, I think so. Yeah, I believe it's part of this course. Hold on. let me just look that up. Python D2L. Yeah. Dive into deep learning. Oh, that's why D2, dive into deep. D2L. Okay, nice. I think D2L is for like, okay, where, hold on, what is being used from D2L? From D2L, import torch as D2L. But then we are also importing torch separately. I'll need to look into what exactly this is. Um, but yeah, it's great that they are also going into like probability and statistics. I guess we're going to be learning that as well. And then what's the next thing? I want to look in. Wait, this is interesting because this is going into the math of everything as well. It's teaching you the math of all of this. Now, see, I could do this. The thing is, I'm not a complete beginner in deep learning, right? So I don't know to what extent I should be focusing on the beginner stuff aside from the calculus part. The calculus part I definitely don't know. Linear algebra, for the most part, I do know a bunch of this stuff. I've learned about dot product, I've learned about matrix multiplication, I know about tensors and reshaping them and doing operations with them and all of that stuff. I think we can like directly jump into, hold on. So in under preliminaries, after probability and statistics, there's something called documentation. While we cannot possibly introduce every single PyTorch function and oh, they're telling us to look at the documentation. No, they're telling us to look at distributions. To know which functions and classes can be called in a module, we invoke the dir. Yeah, okay. For instance, we can query all. Oh, they're just teaching us how to explore the API. Okay. Specific functions and classes. Okay, yeah, great. That's our basic Python. Linear neural networks for regulate for regression. Okay, cool. So I guess we're going to be using a neural network for we're going to be using a neural network to predict this. Is that what I'm getting? Yeah, I think so. Yeah, I think so. We're going to be using a neural network to predict the line. The line of best fit is what gets used in the in linear regression. That is what gets used to make future predictions. That line is what we get as a result of our training. Okay, cool. Um, okay, all right, dude. There's there's a good amount of information here. There's a great amount of information here. What are we looking at? What page number is this? 91. Okay. Okay, linear regression is a single layer neural network. Oh, so they first teach us linear regression like here. Wait, linear regression, where's that diagram? Where's the diagram gone? Oh, here. So this, at least in, what do you call it? At least through scikit-learn, when I had done it, the method that we were using to determine the line of best fit the method we were using was the ordinary least squares method, and we didn't have to do that. We just had to call like a couple of functions. We had to hand the data to we had to hand the data to the model, which we would call fitting the model with the data, and then we run a prediction function. Sorry, no, we hand the data to the model. We call fit. When we call fit, that's when it creates this line. It um, calculates the line of best fit and stores it within the model as weights. So that is our because this is a line, so we can use the slope. No, we can use the, what do you call it, the equation of a line, the function of a line, the algorithm of a line. It's y equals mx plus b. So you would predict y by using m multiplied by x plus b. So you already have your x. M is the slope, and b is the y-intercept. Or maybe b is the slope. No, I think m is the slope. M is the slope, which is the measurement of the slope of the line, and b is the y-intercept, which tells us at what point. Um, oh, sorry, I just forgot what y-intercept means. Y-intercept is the value of y when x is 0, isn't it? I think so. Yeah, yeah. It tells us at what point is um at it tells us what the value of y is going to be whenever x hits 0. So x hitting 0 basically means the line is intercepting y. I believe that's what the logic was. I can't remember. But yeah, so wait, moving further, are we not doing that line of best fit method? Let's go down here and see. So they're explaining the neural network thing. Dude, you know what's crazy? I remember drawing this exact diagram. If I still had my science textbook from shit, I don't know what it was. I don't know. I think fifth grade. I don't remember. Yeah, yeah. I don't remember. Um, but yeah, yeah. Sorry. I was just thinking about. So I remember drawing this diagram in in my school days, and then I just completely forgot about it. I don't even think I fully knew at that time what exactly I was looking at. Yeah, yeah. Anyways, so they're explaining. I'm assuming they're explaining to us how neural networks relate to biological neural networks. Okay, object-oriented design for implementation. So this is where they're going to be teaching us how to create our linear regression neural network. Is that what's going on here? In our introduction to linear regression, we walked through. That's what I was wondering. Why has no code been written for doing this so far? So far, we were only looking at the shit. I just realized we are a good, I don't know, half an hour into the stream now, 45 minutes into the stream now, and I'm still on this book. Um, we haven't gotten into the meat of today's stream, which I guess I can rename the stream, and the entirety of the stream can just be us going through this book real quick. So now I'm gonna have two books to go through. One is the Forrest Mims book, And it's not just me going through these books, it's me studying these books and doing research on them bit by bit. Like I've been having conversations with Gemini, trying to understand basic physics, uh, stuff like uh, stuff like attributes of electrons, protons, neutrons, nuclei, atoms, molecules. For those of you who don't know, electrons together with, wait, protons with neutrons together make up a nucleus, and electrons with nuclei together make up an atom, and multiple atoms together make up a molecule, and then molecules join together to, build the stuff around us. So I've been trying to understand how. Sorry, I just realized I haven't been looking at the chat the entire time. Okay, all right. Uh, what was I talking about? Yeah. So, as I've been reading the Forrest Mims book, I got to the point where they start teaching us about silicone, but then there were certain behaviors of things within silicone and within what was being explained just in general, certain behaviors that I wasn't too comfortable with moving forward with that until I properly understood how electrons, protons, and neutrons work. How, like, very basic stuff. I wanted to build up my knowledge on that. And me trying to build up my knowledge on that, it led me to ask Gemini all sorts of various questions, including stuff like, how is it that these things, like, okay, you have, first of all, I found out that electrons are much, much smaller uh, than protons or than nuclei, one of these two, but they're much smaller than them. The analogy that Gemini gave was that if the nuclei or the proton, I think it was saying nuclei, I don't remember. If the nucleus or the proton, one of these two, is a football field, the electron is probably the size of a bowling ball. Like that's the size difference between them, and there's a massive distance as well between the electrons and the nucleus or the nuclei. They're kind of orbiting, but there's a massive distance between them. They're not tightly packed together. The proton and neutron are packed together to make up the nucleus. Um, and it turns out the nucleus is what keeps the protons from kind of just shooting out, because like charges repel, and unlike charges attract, right? So if we have a bunch of protons, and protons are all positively charged ions, or, well, no, sorry, positively charged ion would be the entire atom itself. If protons are all positively charged, and like charges are supposed to repel, then why is it that the protons are not just kind of exploding and pushing each other apart? And it turns out that the neutron is responsible for that, or the neutrons are responsible for that. So you see, there's all of these different physics related questions that I have, various doubts that I have about how all of these things are forming, the solid matter that we are able to hold in our hands. I want to understand all of these things properly before I move further to learn about silicone. That being said, I feel like I'm making good progress now. As soon as I'm done with this the Git learning thing, um, and I've started using Git as part of my regular workflow, then I want to continue with the Forest Mims book and continue with our ESP32 stuff. And now I feel like I want to add this to the list as well. And so now I'm wondering if I should do this on stream, do this deep learning studies on stream, going through this book basically. I kind of feel like if we start going through this book, I think the entirety of the introduction, we're going to be done with this like real soon. Because the stuff that I don't understand, it only starts at like calculus. Calculus is where I need help because I just never got a chance to learn calculus. And so basic calculus stuff like derivatives, differentiation, um, I don't know if gradients are basic calculus. Calculus? No, I don't know if gradients are basic calculus, but I'm going to add it in there. Partial derivatives, that might be basic calculus as well. I never got a chance to learn any of these things. So I'm gonna need to take some time with this. For the other stuff, we're probably just gonna like breeze past it. We're gonna read about it, practice it a little bit here and there. Massive advantage for me here is that I already know NumPy. Um, I know pandas as well, even though I would prefer to move over to polars as soon as possible. But I know pandas, so that's an advantage if we, need to pull data from some sort of data set that is stored as a CSV. I'm trying to remember if there have been any situations where I was able to directly use the data. I think it was, yeah, I think the data was like in a different form there. Because like how was, let's say, the fashion MNIST data set being stored? I don't remember what it looked like on file. I don't remember even checking what it looked like on file. Because like, okay, you have I'm pretty sure they have to have pointers to the files because the images themselves are like individual files. And then you'll have like, one big data set containing like various labels and the image that the label points to. The label is basically the classification of the image, the correct classification of the image. But yeah, okay, let's continue with this. Object-oriented design for implementation. Wait, let's read this a little bit. In our introduction to linear regression, we walked through various components, including the data, the model, the loss function, and the optimization algorithm. Indeed, linear regression is one of the simplest machine learning models. Training it, however, uses many of the same components that other models in this book require. Speaking of other models, by the way, this book, the reason I was even more interested in this book is because it covers a lot of the basic deep learning stuff that I've been meaning to learn and then some. So, like, there's even more after that. Um, like, for example, I'm pretty sure it's going to go into feed forward neural networks at some point, right? Our linear neural networks for classification. I'm pretty sure at some point, like it's going to go into feed forward neural network. Then what is builder's guide? Layers and modules. Oh, I think this is teaching us about how to do all the neural network related stuff as in building neural network related stuff in PyTorch. I think this is covering that. Anyways, in terms of different types of models, different types of architectures, it covers convolutional neural networks, so CNNs, then modern CNNs as well, whatever that means, then RNNs, recurrent neural networks, then modern RNNs, again, whatever that means. Then it covers attention mechanisms and transformers. That's what I'm aiming for, like eventually to be able to do. I just noticed this as well. It goes into computer vision, NLP, and something that caught my eye earlier. is reinforcement learning. It covers reinforcement learning as well. So there's a bunch of like very there's GANs as well, generative adversarial networks. So there's a fair bit of stuff that we can learn from this book. And in terms of trying to understand, in terms of taking my first steps into deep learning, which admittedly I've taken a very long time to do, I feel like this book is gonna be beneficial because anyways I was planning on, dude, you know what's crazy? It says here inspired by the open source libraries such as PyTorch Lightning, at a high level we wish to have three classes. But okay, yeah, PyTorch Lightning. Something happened with this package recently, so it's kind of funny that this is mentioned right now. The package was compromised in some way. Hold on. Um, yes, the widely used Python package Lightning, associated with the deep learning framework formerly known as PyTorch Lightning, was compromised in a major supply chain attack. Compromised versions, so and so. Trigger: the malware executed automatically the moment the package was imported into a script. Payload: it silently downloaded the JavaScript runtime bun and executed a massive, obfuscated script to steal AWS, GCP, Azure, and GitHub credentials. Okay. The malware then used these tokens to silently commit uncoded, to silently commit encoded data back to exposed user repositories. Timeline: the malicious wheels were on PyPy, published to PyPy on April 30th, 2026, but were rapidly flagged by security scanners and quarantined by PyPy. Okay. Yeah, that's what I was wondering where I was remembering this from. It's crazy, dude. The amount of supply chain attacks that are happening now. I'm so glad that I never got caught up in any of them. But holy shit, dude. That's crazy. That is crazy. Give me a second. I'm just looking at something. Okay, yeah. Sorry about that. I was just looking at something. Okay, so back to this. Okay, At a high level, we wish to have three classes. Module contains models, losses, and optimization methods. Data module contains data loaders for train. Hold on. Why is it saying this as if this doesn't already exist? Hold on. Sorry. Why is it saying this as if it doesn't already exist? I'm gonna ask Gemini this question because I'm curious about this. Hey, I'm reading the um, Dive into Deep Learning D2L book. I noticed on um, where are we right now? I'm pretty sure we are in this and object-oriented design. I noticed on page 94, which is linear neural networks for regression, and then object-oriented design for implementation. They mentioned the following. Inspired by open source libraries such as PyTorch, Lightning, at a high level, we wish to have three classes. One module contains models, losses, and optimization. Because I'm trying to figure out if this was written before the PyTorch API became what it is today. Yeah, I'm trying to understand if back up, dude. Am I making a mistake here? Hold on. I need to continue reading this. Data module provides data loaders for training and validation, and then both classes are combined using the trainer class, which allows us to train. I could have, like, I have the entire thing open here. I can just copy this entire thing, dude. What am I doing? Yeah, I have the thing open right here. Let me just copy this. I'm a bit confused. Why are they talking about the API as if it doesn't yet exist? Should I be looking at this? Actually, the answer would still be yes. I should be looking at this book. Because like there's a lot of other stuff that I'm gonna get to learn, even if the code tends up, even if the code tends to be or ends up being tends up. What the fuck? even if the code ends up being on the older side. Um, okay, Gemini responded. That part trips up a lot of people when they first read D2L. It sounds like they're designing a library from scratch in front of you, and that's exactly what they're doing. The authors of Dive into Deep Learning made a deliberate structural choice. Instead of just teaching you how to use PyTorch or MXNet out of the box, they built their own custom lightweight wrapper library called D2L specifically for the book. Oh God, dude. Holy shit. Wait, so yeah, I wasn't making a mistake. I would have been making a mistake not to continue with this book. That's crazy, dude. Hold on. Okay, here's why that paragraph sounds like a blueprint for something that doesn't exist yet. One, you are building the D2L library with them. Throughout the book, you aren't just using raw PyTorch, you import a utility package via import D2L. In that specific section on page 94, the authors are introducing the object-oriented architecture they designed for the book's companion code. They write it like a design proposal because sequentially in text, you haven't implemented or seen those classes yet. They are setting up the architectural mental model before they show you how to use the code for d2l.module, d2l.data module, and d2l.trainer in the subsequent sections. Then two, the the PyTorch Lightning connection. The authors mention PyTorch Lightning because it's a highly popular real world industry framework that separates research code, that is the model architecture, from engineering code, which is the training loops, hardware scaling, and data loading, etc. Instead of forcing you to write 50 lines of messy, repetitive training loops for every single chapter, the D2L authors thought, hey, PyTorch Lightning has a brilliant API design. Let's build a mini simplified version of that structure just for our book so our code stays clean and scalable. Okay, okay, that makes sense. How it breaks down in the book. When you move forward, you'll see they use a special Python trick, an at the rate so and so decorator to incrementally piece these three classes together across the chapters. Module handles the what, that's your neural network layers and your loss function. Data module handles the inputs, wrapping your training and validation datas, data sets data sets into clean batches, and trainer handles the how, that is the actual loops that feed the data into the module. Oh, sorry, that feed the data into the module, calculate gradients, and update the weights. All right. So don't worry, the API absolutely exists inside the D2L package you install. They are just taking off the hood to show you the engineering blueprint of why they built it way before what? Oh, of why? Oh, they're taking off the hood to show you the engineering blueprint of why they built it that way before you start using it. All right, good to know. Good to know. So we are going to be learning quite a bit here, which is great, which is awesome. Um, I'm realizing something, or I guess I'm having a question. I'm wondering something. Would I be unnecessarily extending the amount of time that it's going to take me to learn basic deep learning neural network architectures. Because my plan was not to build things from scratch, as in, no, to be clear, my plan is to build neural networks from scratch. My plan is not to build um, a neural network building framework from scratch. My plan is not to build a deep learning framework from scratch. And while I don't mind learning this stuff, I feel like this might extend the amount of time that it takes me. Yeah, I kind of feel like this might extend the amount of time that it takes me to learn the basic stuff. Okay, let me try asking Gemini. Maybe Gemini has like read through this paper and can tell me. I should probably use yeah, maybe I could feed the well, I'm sure Gemini has read the book. Hey, so I'm concerned about something. I do want to learn how things work on the low level or how things are implemented. However, my main aim is to learn the deep learning neural network architectures, FCNN, CNN, RNN, transformers, etc. So I can then build neural networks from scratch using frameworks like Torch or some other deep learning frameworks. I'm not trying to implement my own deep learning framework. Um, is that what's happening in this book? Is that what we are going to be doing throughout the book? Um, implementing the functionality for each. Sorry, zoned out. Um, implementing the functionality for each neural network, each neural network architecture, or do things go to a higher level uh, for later chapters? I totally get that concern. When you're trying to learn the actual science and architecture of deep learning, the last thing you want is to get bogged down in software engineering and building a custom framework. The short answer is no, you're not going to spend the whole book building a framework. What you are seeing in chapter 3 is a one-time structural setup. The authors built that custom D2L wrapper early on precisely so they can hide the repetitive engineering boilerplate later. This allows the rest of the book to focus exclusively on the high-level architecture implementations like CNN, RNNs, and transformers using standard PyTorch tools. Here's exactly how the book balances quote unquote from scratch with the high-level frameworks as you move forward. The D2L formula, concise and high level, from scratch implementation. This shows you the mathematical equations of the architecture implemented in raw PyTorch tensors using basic operations like matrix multiplication. This ensures you actually understand the math and aren't just treating the architecture like a black box. Crucially, these are only 10 to 20 lines of code. You aren't building a framework, you're just writing the explicit math. Then, the concise framework implementation. Immediately after, they show you the real world way to do it. They throw away the raw math code and show you how to build the exact same network in 5 lines of code. Oh, using standard high level PyTorch APIs like torch.nn.linear, torch.nn.conv2d, etc. Okay, what later chapters actually look like. As you advance into complex architectures, the quote unquote from scratch parts organically fade into the background because doing things from scratch becomes too complex and inefficient. By the time you get to the modern CNNs like ResNet, VGG, etc., RNNs, and transformers, you will be operating at a highly functional, framework-driven level. You'll be using PyTorch's built-in layers to construct the networks, and you will use the D2L trainer class you saw on page 94 to train them in a single line of code. All right. Okay. You know what? That is reassuring. Okay. That is definitely reassuring. Okay. So we're writing a bunch of code here. Um, It definitely looks like a lot more than just 10 or 20 lines of code. I'll say that, but that's fine. That's okay. We're still doing D2L. Okay, okay. Concise implementation of a data loader. Okay, all right. You know what? I think I might need to go through this for at least a little bit because I do remember having doubts about, how does this work? How does that work? How are things working on the lower level here and there? I was, curious about what data loader is loading, and there was one more data related words. Holy shit! What data loader is loading, and there was another data loader related or another data related class. I can't remember what it was called. Yeah, yeah. I can't remember what the thing was called. Maybe it was just data set. One was data set, one was data loader. Or maybe these were two types. I can't remember. Okay, anyways. Linear regression implementation from scratch. All right. Defining the model. Okay, okay. So we are defining this as a neural network. Cool. Defining the loss function. Okay. Training. Okay. All right. Concise implementation of linear regression. Deep learning has witnessed a sort of Cambrian explosion over the past decade. The sheer number of techniques, applications, and algorithms by far surpass the progress of previous decades. This is due to a fortuitous fortuitous, let's say fortuitous, combination of multiple factors, one of which is the powerful free tools offered by a number of open source deep learning frameworks. I think we are going towards PyTorch now. Um, Theano, I don't know who that is. Disbelief, okay, arguably represent the first generation of such models that found widespread adoption. In contrast to earlier seminal works like S92, SN2, okay, which provide a Lisp-like programming experience, modern frameworks offer automatic differentiation and convert and convenience of Python. These frameworks allow us to automate and modularize the repetitive work of implementing gradient based learning algorithms. All right, in section 3.4, we relied on um, one, tensors for data storage and linear algebra, two, automatic differentiation for calculating gradients. In practice, because data iterators, it was data iterator. One was data loader and the other was data iterator. I believe so. I believe so. Yeah. Okay. Um, In practice, because data iterators, loss functions, optimizers, and neural network layers are so common, modern libraries implement these components for us as well. In this section, we will show you how to implement the linear regression model from section 3.4 concisely by using high-level APIs of deep learning frameworks. All right. When we implemented linear regression from scratch in so-and-so, we defined our model parameters explicitly and coded up the calculations to produce output using basic linear algebra operations. You should know how to do this, but once your models get complex, and once you have to do this nearly every day, you'll be glad for the assistance. The situation is similar to coding up your own blog from scratch. Doing it once or twice is rewarding and instructive, but you would be a lousy web developer if you spent a month reinventing the wheel. Sorry, zoned out. For standard operations, we can use a framework's predefined layers, which allow us to focus on the layers used to construct the model rather than worrying about their implementations. Recall the architecture of a single layer network, as described in figure so and so. The layer is called fully connected since each of its inputs is connected to each of its outputs by means of a matrix vector multiplication. In PyTorch, the fully connected layer is defined in linear and lazy linear classes. The latter allows users to specify merely the output dimension, while the former additionally asks for how many inputs go into this layer. Okay, defining a loss function. Okay, mini batch SGD is a standard tool for so and so. PyTorch supports. Okay, cool. Training. Okay. Um, all right. Hold on. We're going to generalization. Okay, weight decay. What is weight decay? Now that we have characterized the problem of overfitting, we can introduce our first regularization technique. Recall that we can always mitigate overfitting by collecting more training data. However, in the short run, what? No. However, that can be costly, time-consuming, or entirely out of our control, making it impossible in the short run. For now, we can assume that we already have a much high quality, as much, sorry, have as much high quality data as our resources permit and focus on the tools at our disposal when the dataset is taken as given. Okay, wait. We'll look into decay later. Right now, okay, this is still okay. Okay, all right. Um, Linear neural networks for classification. Softmax regression, classification. Okay, where are we now? Oh, okay. All right. We need to scroll down. Oh, okay. There is a lot of information here. Okay. How much more is in this list? We are still here. There's still three more chapters left. Okay, so then it goes on to multi-layer perceptrons. Okay. So this is our feed-forward neural network, isn't it? The multi-layer perceptron? I think so. Okay, wait. We'll find that out later on. Um, After this, we move on to wait. Even in multi-layer perceptron, in terms of code, what are we doing? Okay, all right. It's just being passed through ReLU. Wait, what about here? Is there any code? I'm not seeing code, but there is theory for it. All right. How does the convolutional neural network section look? From fully connected layers to convolutions. I thought this was candy. Like at a quick glance, as I was going through this, that looked like the entire image looked like candy. Okay. Um. Okay. Okay. So they explain the math, and I want to look at what the code looks like. Dude, okay, I'm gonna be honest, I'm not too sure about this. Because it's great to learn this stuff, but I feel like if I introduce way too much math in there, um, it's gonna take me way too long. I don't know. I'm not too sure about this one. I'm not too sure about this. You know what? I'll consider this. I'll consider this and then maybe you know what? Something that I do want to look into, even if I don't, if even if I end up not reading this book, something I definitely want to cover, or something that I don't want to ignore, is this, the calculus part of things. I want to, at the very least, I want to learn the calculus part of things, and then leave. If I am going to leave, then I want to learn, at the very least, I want to learn the calculus part of it, and then leave. But you know what? Okay, that's going to be it for today's stream. I'm going to end the stream here. I have to go and check on something. And off stream, I'm going to continue doing the Git stuff. I'll try and make more progress. I guess I'll read up on the remotes and branching and stuff like that. I'll also finish, reading those conversations that I was having with Gemini about, various inner workings of like the bare repo and how things are working. How is it that we weren't getting an unrelated histories error when we tried to pull from the bare repo? Or sorry, when we try to clone and like internally, if we are doing all of the clone steps manually, then at some point we have to check out the branch from the remote tracking branch, and we have to like merge that with our main branch. It turns out that the reason we don't get an unrelated histories error is because there is no history. It's a brand new thing. It's a brand new repo, so there's nothing to collide with. But yeah, okay. I'm gonna continue reading this stuff. I'll try to make as much progress as I can before tomorrow's stream, and hopefully then we can jump into branches and tagging, and then finally we'll be done with Git stuff, and I can just start using Git regularly. But yeah, dude, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.